quite sure how to follow that, but at least I can say what I'm going to talk about does exist. Okay, so my name is Ian Williams. I am the chairman of the SPEC GPC committee. I'd like to just go through some quick slides, give you a quick update of what we're doing at the SPEC committee as it relates to OpenGL. And in particular, we're in the process of development of a new version of ViewPerf, specifically ViewPerf 12. So a quick show of hands in the audience. How many people have heard of ViewPerf, know of ViewPerf? Okay, that's good, a good number. So at least some of you know what I'm referring to. So for those of you who don't know the background of the SPEC committee, and in particular the SPEC GPC group, the SPEC committee in general creates unbiased benchmarks, and in particular the GPC committee focuses on graphics applications and really measuring performance at a system level, graphics performance at a system level. We developed the benchmark called SPEC ViewPerf, which is intended to sort of represent the OpenGL usage of a number of fairly major OpenGL applications and applications that are used in typically the professional graphics space. And also the committee is constructed of members from AMD, Apple, Dell, Fujitsu, HP, Intel, Lenovo, NEC, and NVIDIA, and has been around for many years. So again, for those of you who are maybe a little unfamiliar with ViewPerf, the SPEC ViewPerf 11 we felt was a fairly major step forward from the previous ViewPerfs. In particular, it actually included a GUI, so we were a little bit behind probably nearly every application, but that was a fairly major step forward, and that actually made the running of it a lot easier. You could change variables, things like resolution, multiple runs, presented the results in an easier fashion, and so on. The other big change that we did with ViewPerf 11 was we wanted to include bigger, more realistic view sets. The vertex counts on some of the data sets are up into the 50 million, so 25, 50 million level, so we have to keep doing that to keep challenging the graphics hardware. And also we refreshed the traces that the view sets were built on from newer versions of the application, so that as the applications move forward and take advantage of new features of OpenGL, the ViewPerf is moving along with that. And which leads into the next point, that one of the key areas that we included in ViewPerf 11 was the use of shaders, and they actually came from a couple of applications, Lightwave as well as CATIA. As well as the use of things like vertex buffer objects for the more efficient OpenGL paths. So it's, ViewPerf 11 is still free. Go to spec.org and look under graphics applications and you can find the download there. So moving on to ViewPerf 12, one of the things we wanted to do with ViewPerf 12 was actually go through effectively a complete rewrite. So from the ground up, ViewPerf 12 is completely restructured and reorganized to, and I'll go into a little bit more detail in subsequent slides, but it's literally a ground up rewrite. There is, and one of the reasons was that we felt over time ViewPerf, the way of actually creating view sets for ViewPerf was fairly complicated, it's fairly time consuming. It ended up whereby only a few people and a few member committees were actually doing that. So we wanted to try to create a new way of actually being able to generate view sets. So as I say, this prompted us to really rethink about how ViewPerf measures and benchmarks and so on. And essentially, as part of that, it's a lot more flexible than the old ViewPerf used to be. Supports OpenGL, but allows us to support some of the features of newer OpenGLs quicker. Also, we can support the other API that no one mentions, the OpenGL BOF. But other APIs like OpenGL ES are actually really easy to include. We tried in previous ViewPerfs to include OpenGL ES, and it was a fairly major exercise, whereas really the timing framework and things like that of ViewPerf is so simple now that it is really easy just to test other APIs on it. The other thing, as I mentioned, we wanted to make it much easier to add view sets. Essentially, each view set, in the past, a view set comprised of things like geometry data as well as maybe textures, other data. It was essentially a trace of the OpenGL command stream, reordered a bit to make sense. You don't want to send the texture every frame when you have like a textured object or something like that. Send the texture once and then just redraw the geometry. But essentially it was there was some kind of reordering of the commands as they came out of the application to make it efficient for actually playback and measuring performance. But it was very close to what came out of the application. What now, with ViewPerf 12, each view set is really just a DLL that ViewPerf loads, and there's some handshaking and sort of agreed upon functions and reporting of data and passing data back and forth. And then the view set the DLL is really the thing that controls the view set. So that allows us to do a lot more sophisticated benchmarking. In particular, some areas, in a lot of applications, it's not just an OpenGL command stream. The application is actually doing other CPU work between its OpenGL commands. And prior to ViewPerf 12, there was no way to measure that. There was no way to actually replay that. So by moving the actual view set as a DLL that ViewPerf loads, it really just hands over the execution of the workload to the DLL, and it can go do whatever it wants. So you can compute new coordinates during the benchmark. You can do many other things. Likewise, really, given an OpenGL command trace, if you can then take that, convert it to C code, and wrap it, then that's a view set. As I mentioned in the previous ViewPerfs, we had to sort of reorder and reshuffle the data that was captured out of the trace, and that was an involved process and was complicated because whenever you try to reorder the trace, you've got to get things like state at the particular time of certain commands, because if you don't have the correct state, then you're not going to be representing what was there. So it was very cumbersome. So now, if you have a trace of any OpenGL application, you can wrap that in C code and turn it into a view set. And from the committee perspective, we look forward to this because that opens it up for a lot more people to contribute workloads. Some of the other things as well, it's portable to many OSs. I mean, again, we'd had various, ViewPerf was available on Windows and Linux, but there were some complications. Now, with a simplified framework, the framework is really just C code that handles timing and moving data and reporting results, and that's all pretty straightforward. And likewise, the DLLs and the equivalents on Linux, that they're intended to be a lot simpler to move between different platforms. And so this is some of the really exciting areas that we see from ViewPerf 12 is we can open the door for a whole bunch of view sets that we couldn't attempt before in ViewPerf 11. So some of the ones that we want to look at immediately are things like volume rendering, where you may be computing different coordinates every frame, but because on a simple trace and playback mechanism, all the data was fixed, you can't do that. Whereas now we can compute vertices or texture coordinates or whatever you want to do during every frame, and even though it's CPU work, but that's what the real applications do. So those can be modeled within a view set. So we hope to be able to represent applications in a lot wider fields than previously. And other areas as well, like computer-aided engineering, where you may have a lot of sort of analysis and dynamic viewing of results on, textures led on, and isosurfaces led on to data. Those are the kind of view sets that we'd like to get more of. So the other important thing, we're not just going to completely come out with a whole new set of view sets. And it's actually interesting that the framework that we have, we've been able to, and Alan Jensen, who's also on the committee at the back of the room, he was able to take the entire ViewPerf 11 view sets and translate them into ViewPerf 12 just by a simple function and a simple utility to convert them, and they just all translate straight across. So that was quite pleasing in terms of our goals of making it easy to create data, and as I say, the conversion of the previous view sets allowed us we can bring those really easily as well, and we're probably going to go through and choose which ones we want to keep and which ones we don't, but at least we don't have to go reinvent all of those wheels. So that's pretty much it. We expect probably later in the year, hopefully before the end of the year, to be able to release the new benchmark. Look for a lot more view sets, look for we'll probably radically change the GUI, so even though with ViewPerf 11 we brought this GUI, things are probably going to change fairly dramatically, but again, hopefully all of that is simplification of the things that aren't related to the actual, we can focus on the workload and the testing and the benchmarking. So With that, I'd like to open up to any questions, if anyone has any questions. Joe?
Doesn't that make the view sets then in ViewSpec 12? ViewSpec 12 dependent on the API and the OS, so that you can't test across different APIs or OSs now?
No more so than last time. I mean, certainly the framework we intend to be in concept the same across the OSs. There may be specifics between OSs, and likewise the view sets that we provide, we certainly will try to make in a platform-independent fashion. But it is a general framework, and yes, you could do things that were specific to one OS and not to other OSs. But that wouldn't be the intent of what we provide from view sets. We'd intend to make them cross-platform.
Okay.
Yes?
I know that one of the focuses up until recently is having these graphics cards go as fast as possible, but it's getting to the point where you have insane speeds, and what you really want is a maximum time that it takes to render a single frame, so you can maintain a constant frame rate. Say, like, if you have a target of 60 frames a second, you never go below that. Is there any of the performance metrics looking at more of what is the minimum, what is the maximum minimum rate rather than the blazing fast everything rate?
Sure, it's a good question. I mean, we've discussed on the committee several times. Some of the challenges with sort of maintaining a constant frame rate type approach is that you may change the workload dependent on the capabilities of the graphics card, and that's something that we want to always ensure that you're comparing apples and apples. And certainly we've had bugs and things like this where really small cards have gone really fast, and it turns out that we're not drawing the same things. And so, you know, to that end, we'd want to maintain that there's an apples-to-apples comparison. But one of the things that we see with ViewPerf 12 is that we actually get more flexibility now to be able to do these more sophisticated drawing loops that maybe look at things like maintaining a constant frame rate, or you know, looking at sort of more behavior during the drawing. And so yes, we would like to start looking at more sophisticated application drawing than we have in the past. Whether those will be exactly a constant frame rate type measurement, we'd have to see as, you know, sort of discussion evolves and we look at the view sets, in specific view sets and specific applications. One of the key driving factors that drives all the view sets that we have in ViewPerf is we want them to be representative of applications. We could, as a committee, go create a bunch of view sets that did really interesting things, but because there tends to be a lot of resources from the entire industry, from, you know, the graphics vendors, the system vendors, as well as driver tuning and things like this, if we were off driving tuning efforts and work in areas that didn't benefit, you know, people who bought graphics cards and computers, then we that may not be a good thing. Any other questions? One more, if anyone's got one. Or otherwise, we'll go on to the trivia. Yes?
So is Spec APC still around? Really?
Yeah, the question was, is Spec APC still around? Absolutely. So Spec APC is a sister committee to the GPC, which APC stands for Applications Performance Characterization. And the focus of the APC committee is a lot more to actually benchmark the applications themselves. And so rather than extracting the graphics workload out of the application and benchmarking that at a system level, the APC benchmarks focus on benchmarking graphics performance and also CPU and I/O performance through the application, which yields different focuses. But again, the intent to be that the industry is able to optimize and deliver better experiences and performance in ways that people can take advantage of. Okay, well, thanks very much. Thanks.